You know, for decades, nuclear energy has felt kinda stuck. It's incredibly powerful, but it's been held back by a rulebook from a totally different era. So what happens when a new generation of reactor technology finally gets a set of rules written for the 21st century? Well, that's the huge shift we're going to dig into today.
This has been the big problem for years, right? You've got all this amazing nuclear innovation, but it's been fighting against a regulatory system that was designed for these massive old-school power plants. The real question is, how do you break that stalemate so you can actually build the power sources of the future?
So, here was the problem. You had all these brilliant new reactor designs piling up, totally ready to go, but they were all stuck in this massive regulatory traffic jam. It's kind of like trying to get a brand new, high-tech sports car approved using the rulebook for a steam locomotive. The system just wasn't built for them.
And you can really see the difference right here. The old rules, parts 50 and 52, were super prescriptive. They basically told you exactly how to build one specific type of reactor, down to the nuts and bolts. The new goal? It's a complete 180. It's all about focusing on the safety outcome, not the exact road an innovator takes to get there.
So, what's the solution? Well, it comes from the U.S. Nuclear Regulatory Commission, or the NRC. After years of work, they've introduced a new, optional licensing framework called Part 53. And this isn't just some minor tweak, it's designed to be a completely new way of thinking about how we approve reactors.
The absolute key here is this idea of performance-based regulation. Think of it like a building code. An old prescriptive code would say, hey, you have to build your walls with 2x4s, and they have to be 16 inches apart, period. But a new, performance-based code says, look, I don't care how you build your walls, just prove to me they can withstand 150-mile-per-hour winds. It doesn't matter if you use wood, steel, or carbon fiber, as long as you can show it meets that safety standard.
So, Part 53 basically opens up a whole new path. It gives developers way more flexibility to innovate, but it also puts a lot more responsibility on their shoulders to prove their designs are safe. And it's a choice, not a requirement. It has the potential for way lower costs and faster approvals, but only if these companies are doing really serious risk analysis from day one.
Right, but a new rulebook is only as good as the technology it's actually for, you know? So what kind of innovation are we even talking about? Let's take a look at a fantastic example, the Natrium Reactor.
This is TerraPower's Natrium plant, and it's being built in Wyoming right now. And check this out, its location is absolutely no accident. They're building it right next to a retiring coal plant. That means it can plug into all the existing infrastructure and, most importantly, provide new, high-paying jobs for a really skilled energy workforce that's already there.
So in its normal, everyday mode, this plant is going to generate 345 megawatts of electricity. That is enough clean power for hundreds of thousands of homes, and it can run 24/7 rain or shine.
But this is where things get really wild. When you look at the construction, the numbers are just staggering. Because the design is so streamlined, it needs about 50% less safety-related concrete, steel, and labor. That one thing could totally change the economics of building new nuclear power.
And on top of all that, it's insanely fuel efficient. The Natrium reactor can get 3 times more energy out of its nuclear fuel than the conventional reactors we have today. That means more power from less material and ultimately a lot less waste. So, you're probably wondering, how on earth does it do all this? Well, the magic is really in the design, and specifically, it comes down to 2 key materials, liquid sodium and molten salt.
Okay, let's start with the coolant. A typical reactor uses water kept at an extremely high pressure. We're talking around 2,250 pounds per square inch just to keep it from boiling. Natrium, on the other hand, uses liquid sodium. It can get way hotter, but it operates at normal atmospheric pressure. That right there makes the whole design simpler, way more efficient, and it gets rid of the risks that come with those super high-pressure systems.
But wait, there's more, and this might be the real game changer. The reactor can store its heat in these gigantic tanks of molten salt. This basically turns the nuclear plant into a giant thermal battery. It can actually boost its power output up to 500 megawatts for over 5 hours, sending that electricity to the grid exactly when renewables like wind and solar aren't available. This makes it a partner to renewables, not a competitor.
Okay, but let's be real, no technology is perfect, right? And the main safety challenge for this design is that liquid sodium is super reactive. It will literally catch on fire if it touches the air, and it reacts pretty violently with water. So that means you need some really careful engineering to make sure that coolant stays safely tucked away inside a closed system.
So you see how these new reactors like Natrium have their own engineering puzzles to solve? Well, turns out the new rulebook that's supposed to help them isn't perfect either. Let's go back to part 53 because experts are already jumping in with some serious feedback on how to make it better.
I love this quote from the Nuclear Innovation Alliance, which is a nonprofit think tank. They say, the rule is flawed but fixable. They believe Part 53 is a huge step in the right direction. But as it's written right now, it might not be flexible enough to really kickstart the commercialization it was designed for.
So they've basically laid out 4 key fixes. First, streamline the rules. Move all the nitty-gritty details into guidance documents, which are way easier to update. Second, allow for different ways to analyze risk, not just one super complex method. Third, clarify the safety goals so companies can use a mix of hard numbers and other evidence to prove their plant is safe. And finally, create a clear off-ramp so projects that started under the old rules can easily switch over to this new Part 53 pathway.
So when you step back and look at the big picture, what do you see? We're watching this incredible parallel evolution. You've got advanced nuclear technology pushing the limits of what's possible, and at the same time, the rules that govern it are sprinting to keep up. Which of course brings us to the final question. Is this combination, this new machine and this new rulebook, the key that will finally unlock a whole new era for nuclear energy?